I wonder what my Uber is. Struggling to find your Uber? You might need automatic number plate recognition. What's happening, guys? My name's Nicholas Renault, and in this video, we're going to be taking a look at ANPR. Now, ANPR stands for Automatic Number Plate Recognition. So we're going to be using a variety of techniques to achieve this. Namely, we're going to be leveraging OpenCV and EasyOCR. But enough on that, let's take a deeper look as to what we're going to be going through. So in terms of what we're going to be doing today, as I said, we're going to be using OpenCV to perform some pre-processing. Then we're going to perform some edge detection. So this is going to help us to find the contours which define where our number plate is. Then last but not least, we're going to be using EasyOCR to actually go on ahead and extract that text. So let's take a look at how this all fits together. So first up, what we're going to be doing is reading in our image into Python using OpenCV. So this is going to be within our Jupyter notebook. Then we'll apply some filtering, some edge detection, and some contour detection to be able to find out where our number plate actually is within the image. Then what we'll do is we'll actually perform a masking operation. So we'll actually mask out the section that contains our number plate. And that's going to make it a whole heap easier when we go and perform our optical character recognition using EasyOCR to extract the text. Ready to do it? Let's get to it. So in order to perform our automatic number plate recognition, there's 6 key steps that we need to go through. So first up, what we need to do is install and import our dependencies. Then what we're going to do is read in our image and grayscale it and blur it using OpenCV. We'll then apply a little bit of filtering and some edge detection to actually find out where our number plate actually is. And likewise, we'll use contour detection and masking to isolate those components. Then what we're going to do is use EasyOCR to actually extract the text from that image. So we'll actually be able to get the text from the number plate. And then last but not least, we're going to render the result. So we'll actually be able to see the detected number plate as well as the text from that inside of our image. So we'll actually perform an overlay there. Now, in order to do all of this, we're going to be leveraging a number of key packages. So first and foremost, we're going to be using OpenCV. So to grab the documentation for that, you can just go to docs.opencv.org/4.5.0. Now, all of the links, including the completed tutorial, will be available in the description below. So just check the links there. If you want any of this or if you have any questions, by all means, just drop a comment. Now, on top of OpenCV, we're also going to be using EasyOCR. So EasyOCR actually allows us to extract text from an image. So once we've actually detected where our number plate is, we're actually going to use EasyOCR on the top of that to be able to extract the text from the number plate. Now, in order to facilitate using EasyOCR, you need to have PyTorch installed. So to get PyTorch, all you need to do is go to pytorch.org/get-started/locally. Again, links will be in the description. And to go and install it, all you need to do is scroll on down. And what you're basically going to find is that you've got this install wizard here. So basically, you just need to select which version of PyTorch you want. So say we wanted the stable version, what operating system we're using, so whether or not you're using Linux, Mac, or Windows, how you want to install it. So say you wanted to install it using Conda or pip or libtorch or source, then you just select that. What language you want to install it for, we're obviously using Python today, and whether or not you've got CUDA. So CUDA is going to be an acceleration library that you use if you've got a GPU installed. In this case, this machine's got 10.1, so I'd select 10.1. Then all I'd need to do is copy down this command and run it inside of a command prompt or a terminal, and that's going to go on ahead and install PyTorch. Now, I've already got it installed, so we can skip through that step, but this is how you'd go about installing it if you're doing it for the first time. Perfect. So now if we head back to our Jupyter notebook, we're actually going to kick off and start installing and importing our dependencies. Now we've got 2 key dependencies that we're actually going to need. So aside from OpenCV, we're going to need EasyOCR and IMUtil. So let's go on ahead and install those. Okay, so those are our 2 dependencies installed. So what we've done is we've used the pip install command. So you can see here we've typed in pip install EasyOCR. So this is going to install EasyOCR. And then we've also run a second command, which is pip install IMUtil. So this just helps us with our contours once we get those detected. Now what we can do is actually import them into our notebook. So let's go on ahead and import that as well as the other dependencies that we're going to need. Alrighty, so we've now gone and imported our dependencies. So we've got 5 key dependencies that we've just gone and written in a single cell here. So the first one is OpenCV. So to import that, we've written import CV2. The second dependency is matplotlib. So in order to import that, we've just written from matplotlib import pyplot as plot or PLT. Then we've imported NumPy. So to do that, we've just written import NumPy as NP. And we've also imported IMUtils. So to do that, we've written import IMUtils. And last but not least, we've imported EasyOCR. So to do that, we've written import EasyOCR. Now, the next thing that we need to do is actually go on ahead and read in our image and perform some grayscaling. Now, if we actually take a look inside of our directory, we've got 4 images. So image 1, 2, 3, and 4. Now, again, I'll make these images available in the GitHub repo. So if you want to grab these, you can use them. So in order to read these into our notebook, we're just going to use the OpenCV IMRead function, and then we'll perform some grayscaling. So let's go on ahead, read it in, perform our grayscaling, and then take a look at it. Alrighty, so that's our image read in, grayscaled, and then visualized. So in order to do that, we've written 3 commands. So the first one that we've written is cv2.imread, and then we've passed through the name of the image that we want to read. So in this case, we've passed through image 2, and you can see that we've got image 2 there. Then what we've done is we've gone and recolored it. So to recolor, we've used cv2.cvtcolor. So this basically allows us to convert from a single color code to a different one. Now in this case, what we've done is we've passed through our initial image, which was stored in a variable called img, and then we've passed through the color code conversion that we want to do. So in this case, we've passed through BGR because when CV2 reads it into the format of blue, green, red. And then we've converted it to gray. So you can see here that this entire command here is cv2.cvtcolor. We've passed through the image we want to recolor and then the color change code, so BGR to gray. Then what we've done is we've gone and showed it using matplotlib. So whenever you're displaying an image using matplotlib, matplotlib expects RGB. Now because our image by default is in BGR, we've just gone and applied another color conversion there. But likewise, we could drop this if we weren't too concerned with what it actually looks like, and we're going to be able to see that image here. But you can see this looks a little bit weird right now, so we're going to make sure that we have that conversion property. And you can see we've read it in as gray. Now the next thing that we're going to do is apply a little bit of filtering as well as applying some edge detection. So our filtering is basically going to allow us to remove noise from our image, and our edge detection is actually going to be able to detect edges within our image. Now I actually found an absolutely amazing tutorial out there that actually gives a really great explanation of how these work. Again, I'll link to these in the description. I believe it's from Circuit Digest. But let's go on ahead and actually perform our filtering and our edge detection. Alrighty, so we've now gone and applied our noise reduction, and we've done that using the bilateral filter method. So to that, we've passed through our image that we want to perform our noise reduction on. So in this case, we've passed through our gray image that we had up here, and then we've passed through a number of properties. So these allow us to specify how intensely we want our noise reduction and our smoothing. So in this case, 11, 17, 17 seem to work pretty well. Then from that, we've actually gone and performed our edge detection. So for that, we've actually used the Canny algorithm. So this allows us to detect edges. Now again, we've got a number of parameters that we can pass through, and these can be tuned depending on what you find actually works. But ideally, you want to be able to see these edges exactly or similar to what you're seeing in the image below. Then what we've done is we've used a similar line to what we had up here to go and visualize it. So again, we've applied our CVT color method to make sure it displays appropriately when using matplotlib. So now if we take a look at our image, you can see that we're better able to see each of those edges within our image. So we can start to see where our number plate is. So we can see that we've got a definite contour around there. We can also see the different edges of our bonnet as well as our grille. So you can see that we're applying some filtering. So it's starting to become more evident to us as to where our number plate actually is. Now the next step that we need to perform is actually contour detection. So contour detection is all to do with detecting where these lines are and detecting polygons within those lines. So ideally shapes within our images. Now what we're actually looking for is a contour which has 4 points. So ideally we want to be able to see a rectangle because that's most likely going to be the shape of our number plate. So let's go on ahead and do that. Alrighty, so we've now gone and found our contours. So let's take a look at what we've written there because we've written quite a fair bit. So the first component to finding our contours is actually finding them. So to do that, what we've done is we've used cv2.findCountours. So this basically goes through our image and tries to find shapes effectively, aka contours. So to that, what we've passed is our edged image. So this is effectively our image that we've applied edge detection to. Then what we've done is we've specified 2 arguments. So the first up is how we want our results to be returned. In this case, we've returned a tree. So this basically allows us to traverse our tree to find different levels of contours. Then our next argument is how we want our results returned, or what type of results we want. So basically by passing through chain approx simple, what we're going to get is a simplified version of the contour. So ideally if we find a line, we don't want to represent every single point on that line. We want to approximate the 2 key points that represent our line. So this approx simple algorithm basically allows us to approximate what the actual contour looks like. So ideally what you should get is a contour with 4 points for our number plate section. So basically for our find contours, we've used cv2.findCountours. Again, we've passed through our edge detection image, specified that we want a tree, and then specified that we want to approximate what that contour looks like. Then we've stored that in a variable called key points. Then what we've done is we've used IMUtils to go and grab our contours. So this basically simplifies how our contours are actually returned. And then we've gone through and sorted them and returned the top 10 contours. So to do that, we've used the Python function sorted. We've passed through our contours and we've specified how we want to sort. So in this case, we're sorting by contour area and we're specifying reverse equals true. So this ideally should mean we're going descending. Then we've returned the top 10 contours. Now the next thing that we want to do is loop through each one of these contours and see whether or not they actually represent a square or a number plate. So we're basically going to be checking whether or not there's 4 key points within those. So let's go on ahead and do that. Alrighty, so there we go. So we've now gone and filtered through our different contours in order to find the location of where our number plate might actually be. So in this case, what we've done is we've set up a temporary variable called location, and then we've looped through each one of our contours that we had up here. So this, remember, was our sorted contours list. Then what we've done is we've used the OpenCV method, approx_poly_dp. So this allows us to approximate the polygon from our contour. Now, in this case, we'll pass through our individual contour at a point in time. And this next parameter basically allows us to specify how accurate or fine grain our approximation is. So say, for example, we've got a contour that has a whole lot of little dents in it. How high we set approx_poly_dp is going to round off that contour. So say, for example, you had something which is roughly a rectangle but had a couple of little dents. The higher we set this number, the more rough the estimation is going to be. So basically, it might skip over those little dents and specify that that's really a straight line. So play around with this if you're not getting appropriate results. But what I found is setting it to around about 10. Ideally, make sure that it's fine enough to detect a square, but not too fine that it's going to say that it's got more than 4 key points. Now that brings us to our next line. So what we're basically saying is that if our approximation has 4 key points, then we're going to specify that as most likely our number plate location. So, and then in this case, we've output our location. So you can see that these are the coordinates for our number plate within our image. Now, if we actually take a look at this, what we're basically saying is that it starts out at around 152, goes down to 153, 160, and that basically gives us a reasonably good approximation of this section here, so where our number plate actually is. But at the moment, we're not actually seeing that, so it's probably useful to actually apply some masking and really isolate that section out. So let's go ahead and do that. And there you go. So we've now gone and masked out our image and actually shown it back. So you can see here that by applying our contour search, we've accurately detected where our number plate actually is. Now, in order to do that, we've gone and done a couple of key things. So first up, we've created a blank mask. And in order to do that, we've used np.0. So this basically creates a mask that's going to be the same shape as our original gray image. To that, we've passed the shape of our original image. So in this case, we've done that by passing through gray.shape. And then we've specified how we want to fill it in. So in this case, we've specified np int 8. So basically, we're filling it with blank zeros. Then what we've done is we've gone and drawn our contours within that image. So to that, we've passed through our temporary image, which is our mask. We've specified what contour we want to draw. In this case, it's the location that we had up here. And then we've specified how we actually want to draw it and what we want to display in that. Then what we've done is we've gone and overlaid that mask over our original image. So to do that, we've used the CV2 bitwise end function. And this basically allows us to return our segment, or the segment of our image, which actually represents our number plate. So in this case here, you can see that we've extracted COVID-19. That's our current number plate. Now, if we were to go and do this on another image, we could do that as well. So say I pass through image 3, this is actually going to run through the exact same steps and ideally should detect our number plate again. So you can see it's gone and extracted our number plate from that image. We'll stick with our second image for now and then go through the rest, and then we can test out the entire flow on another image. All right, so we're still good with COVID-19. Now, the next thing that we want to do is just isolate this one segment here. So rather than having a whole heap of blank image, we want to just isolate this little section because it's going to make it a lot easier when we actually pass it to EasyOCR. So let's do that. Alrighty, so we've now gone and cropped out our image. So you can see here that we've got an image that purely represents the segment which has a number plate in it. So in order to do that, we've first started out by finding out every single section where our image isn't black. So basically what we're doing is we're storing those in variables X and Y up here. So basically what we're going to get is a set of coordinates which represents all of these sections in here. Then what we've gone and done is grabbed the minimum X value and the minimum Y value to ideally get this point up here. So this is going to be stored in a variable X1, Y1. And then what we've gone and done is grabbed the maximum X and Y value, which should be down here. And we've stored that in variables X2 and Y2. Then what we've done is we've used a little bit of array filtering. So we've gone and grabbed point X1 to X2 plus 1 to give us a little bit of buffer. And this has given us this range over here. So 0 to whatever that number is there. And then what we've gone and done is grabbed points Y1 to Y2 plus 1 to give us a little bit of buffer to get this segment here. So ideally, when combined, we should have our cropped image, which represents our number plate. And then what we've gone and done is we've gone and visualized it down here. So you can see here by typing in plot.imshow cv2.cvt color, and we've passed through our cropped image, you can in fact see that we have gone and displayed our number plate. Now the next thing that we need to do is use EasyOCR to go and read the text within this image. So let's go on ahead and do that. So this is actually relatively straightforward because we've gone and done all the hard work. Now we just need to read that text. So let's do it. And there you go. So we've now gone and used EasyOCR to go and grab the text from that image. Now you can see that it's gone and returned a colon instead of SA, but overall we've gone and grabbed a reasonably accurate estimation of the number plate. So you can see here that it has in fact grabbed COVID-19 with a confidence of about 0.47. Now, in order to do that, we've used the EasyOCR reader method. So this instantiates our reader. So first up, what we've written is EasyOCR.reader, and then we've passed through the language that we want to use. Then what we've gone and done is we've used our reader, which we specified here, and we've used the read text method on our cropped image, which is this. Then what we've gone and done is we've printed out our result, and you can see that this is our entire result component here. Now, a key thing to note is that whenever you're performing automatic number plate recognition, your results will vary depending on the image that you're working on. So in this case here, we've gone and extracted those two little dots, and that's because we've got some residual text. Now, in terms of how you'd improve this going forward, you might actually choose to use deep learning and train a model that's actually able to classify the image and extract the text out of that. You might also choose to perform some additional image filtering to strip out those images as well. Now, say for example, we use this on another image. So say for example, we used it on image 1. Again, if we scrolled all the way through, so again, we've detected our number plate. And so in this case, because we didn't have any additional text floating around, it's performing a little bit better. So you can see we've got hr.26.br.9044. So it's actually performed pretty well there. Now, if we tried it on image 3, and again, all these images will be available in the GitHub repo, so you should be able to pick them up. All right, so our number plate's BJY982. And in this case, so it's classified the Victoria here, so VIC as G, but in this case, it's classified the rest pretty correctly. So BJY.9B2. So, all right, so classified the 8 as a B, pretty close though. In this case, what we're going to do is just use image, we'll use image 2, so stick with it. And the last thing that we need to do is just go on ahead and render our result. So we're basically going to take our number plate and overlay our detection on the original image. So let's go on ahead and do that. And there you go. So we've now gone and rendered our result to our image. So in order to do this, what we've gone and done is first specified our text. So we've gone to the result returned by EasyOCR, and we've grabbed our first instance here. And then we've used -2 to go from the end of our array to pick up our result. So -1, -2 gives us this text here. Then to go and overlay our results, what we've gone and done is specified our font. So in this case, we've specified font Hershey Simplex. We've then gone and applied our text, which is this component here. So to that, we've passed our image, our text, and then the location that we want it. So in this case, we've gone and specified the bottom corner +60, so it's a little bit further down. Specified the font, our font scale, our font color, our thickness, which we've set to 2, as well as our line type. Then the next thing that we've gone and done is drawn our rectangle, which is our green rectangle here. And so to that, we've passed through our image, we've passed through our first tuple, which gives us our first coordinate, and then our second tuple, which gives us our bottom coordinate, and that draws our image. We've then passed through the color that we want, so 02550 is going to give us this bright green, and then our line thickness, so we've set that to 3. And then what we've gone and done is visualize it. So again, using plot.imshow and then CV2 CVT color, so we've gone and converted it from BGR to RGB. Now, in this case, you can see that we've accurately detected our number plate. Now, what we could also do with this pipeline is just change our image. So in this case, say we change it to image 1, we could actually just step through it all again. And ideally, what you should get is, again, another number plate. So again, it's detected our number plate and printed out our result. We could apply it to image, I think we had up to image 4, so let's try that. So again, it's detected our number plate. You can see it there. Grabbed our number plate. Now this should be a pretty good result because you can see that the text is quite clear. We don't have any additional stuff. So in this case, it's detected H982FKL pretty accurately. If we go and visualize that, so it's gone and detected our number plate and overlaid our text. So it's localized pretty accurately there. And again, because this is a really clear image and you can really clearly see the number plate. But again, your results may vary depending on what your images look like. But that about wraps it up. So we've now gone through a full-blown tutorial on automatic number plate recognition. So we started out by installing and importing our dependencies. Then what we did is we read in our image, we grayscaled it as well. We then applied a little bit of filtering, found some edges for localization. Then we found our contours and worked with them to go and crop out our image. We then used EasyOCR to go and grab the text out of it and find what our number plate actually represents. And then last but not least, we went and rendered our result. Now again, this entire notebook is going to be available on GitHub, so just check the description below. You'll be able to pick it up. And that about wraps it up. Thanks so much for tuning in, guys. Hopefully you found this video useful. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of when I release future videos. And let me know how you went about detecting number plates. Thanks again for tuning in. Peace.